Payload.
Okay, same payload and same, we're not going to release yet, same payload and 4 breaths per balloon after we stretched the second balloon so its released air size was the same size as the other original balloon's empty size. Okay, so each one is stretched to 4 big breaths, adult sized breaths, and the same payload. And now let's see what happens.
3, 2, 1, release. I'm still went out first.
But it reached the end. So I gave it 4 breaths instead of 3 breaths. And the original balloon still released its air slower for some reason.
But it's still, but the
So, okay, so here, that's another factor then. What's the factor, guys?
slower the slower air comes out does not mean the farther it will go.
Are you sure about that?
Because that one's air came out slower and it still made it to the end.
It conserved its energy.
Yes, that's what I'm trying to say.
Okay.
It's like mine goes off first, and it releases some of its air.
It released most of its air first.
Sorry. And then Joshua's doesn't start up until mine goes out, which makes it go all the way, I think.
Well, the question is, because I'm not there on the other to see, when you guys released it, was yours the back end where it's all twisted to hold the air? Was it fully untwisted before you released it?
It sort of got twisted. It didn't come untwisted until mine came undone.
Okay.
Until mine.
So I think it was like a second.
So yours was kind of like a secondary burn.
Yes.
Okay.
Mine was the.
Something we didn't predict happened.
Well, that's a good part of experimenting. Remember what they said in the video, the Eureka video, is that you want a lot of mistakes. You don't want it to be perfect the first time.
Because the mistakes can lead to better success.
Exactly. You can tweak your system to make sure that it works. Because in your problems, you have to find solutions to problems that you didn't even think would be problems to begin with.
The problem for us was actually timing the engines to go off at the same time.
But we found out that we didn't necessarily want them to go off at the same time, didn't we?
If they had probably gone off at the same time, it would have gone faster, but it probably would have still ended up like 3/4 of the way here.
It very well could have.
So secondary burn is good.
Good to know.
Mine was the first burn. It got about halfway, and then Josh was finished the rest of the trip.
Good to know.
Mine must have unwrapped like around like
Once we got through the doorway.
a little after we got to the doorway.
Yeah, because yours bumped the doorway on the way through.
So it must.
Because it's not quite centered on the door since that thing's in the way down there. All right, so what did we learn today?
We learned that that experimentation is great.
What else, Josh? How about you, Austin? What did you learn today?
With a stronger
A heavier payload?
a heavier payload means it may go faster, but it's holding it down more, which means with all those 4 breaths, it had more fuel, which could go all the way. But whatchamacallit.
And got Mom lightheaded.
That's not what I'm trying to say. It went all the way with the same payload, because it didn't quite make it all the way with the first balloon. So we tried 2 balloons and worked.
Okay. What'd you learn, Chloe?
Well, I learned that when you have the balloon by itself with no payload, it will spiral, sort of like it would if it wasn't attached to the straw and string.
So it kind of goes through like a football.
But when you put your payload on it, it stables it out and it kind of weighs it down a little more. So where if you have the same amount of breaths in each balloon, or in say like you use 1 balloon, it makes it a little harder for the balloon to get where it needs to go.
Can I add on to that?
Sure. You can relax it, yeah.
My thinking is that 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 it was wasting energy doing the spiral. So the stabilizers didn't make it waste the energy, even though it was weighing it down. I think it would have produced the same amount of energy if it were spiraling.
Spiraling.
Yeah. Than with the payload.
Good observation. Anything else?
Secondary boosters are great.
Sometimes they're necessary.
And
The more payload, the more fuel.
but I also noticed that when I accidentally left the line a little slack, it didn't make that big of a difference. It's the balloons with the payload still got in the same place. It still got stuck in the same place.
Why would the line being slack make a difference? Let Chloe answer it.
Well,
Look.
I mean, I think it would have to have more energy to come back up from the slump it was in.
You slow it down.
Well, because it would always be fighting uphill if that were the case, because the weight would, wherever it was, would be its down position, right? So it's constantly moving upward, and when it's moving upward, what does that mean?
It's
Using more energy.
Exactly, it's using more energy to move upward, so you're spending your energy doing less work. I mean, more work. You're working harder, not smarter. Right?
I was gonna. Can I add on to that? Also, if the line is slack, it might the straw might catch on like a bump in the line, and that also might slow it down really fast and use up some of its energy while the engines are firing while it's still.
Okay, good job, guys.
Ooh, yay!